So, good afternoon, everyone. Thank you so much for taking the time to join us here on the Day 2 Super Session for Networking. Today we're focused on security, and we wanted to share with you some really exciting stuff. So, before we get all forward into the exciting stuff, because I'm really excited by it, just to introduce myself, I am Steve Shaw. I'm the Vice President of Product Management for the Netscaler line of business. So, if at some point you were really unhappy with a product decision that was made, I am sorry. And you can kick my ass outside the door. Please be nice to me inside the door. So about 2 months ago, we were looking for a presenter, and I found out that Dan Kaminsky was available, and I got all excited. And I had a room full of other peers who kind of looked at me like I was mad, and they were trying to understand why I was so excited. And I'm like, do you not do DNS security for fun? And apparently no one does. So I got to share why Dan Kaminsky is awesome. And for those of you who are not familiar with him, a couple of years ago, how many years ago is it now?
About 8 years.
8 years, okay, time flies when you're having fun. So about 8 years ago, we find out, or Dan figures out, that we've got a massive hole in DNS. I mean, this is like bad in the epic of senses. If this gets out, you basically can take down the internet. And that's kind of a scary proposition. Even 8 years ago, the internet was clearly large enough that for an outage like that was a big deal. And Dan goes over and starts talking to all the guys who own the root servers, coordinates a patch to be deployed simultaneously around the world in all of these critical DNS infrastructure, coordinates with the people who write DNS software to put out patches on the same day, and basically launches the whole thing at once and tells the world, by the way, if you don't want the internet to melt down, please upgrade, right? And at the time I was on the receiving end of notices like that. I got the notice, updated my DNS server. It was actually amazing that it was so well planned and thought out, and it really spoke to his name on the white ops side. He was really thinking about our benefit as he did this, but he really was taking advantage of, deep security techniques to figure out what was going wrong. So when somebody that bright who spends their free time figuring out and hacking on DNS becomes available to come give a talk, you very quickly grab onto that opportunity. So Dan, welcome to Citrix, and thank you very much. And I'm going to turn this over to you, and you're going to tell us what we need to be worried about for this coming year in security.
Awesome. Wow. I just want to say how happy I am to be here. Security is a complicated thing. I'm going to tell you, I'm a bits and bytes kind of guy. I like looking at network protocols, looking at protocol traces, and being like, man, that field is it's going to cause some trouble here. There's a length field inside of a length field. That never ends up well. Turns out security is a little bigger than just the bits and the bytes, though. And that's been my fundamental experience that's had to get beaten into me. Okay, so you found a bug. Now what? We are the caretakers of one of the fastest spreading technologies in human history. When you actually look at the graphs of how fast things have spread, the telephone from 1900 to 2005, the refrigerator, stoves, electricity, these are things that took decades, huge amounts of time for society adapt to, even in the modern era. The internet has reached like 80% penetration, like the 90s to now, 90s to even like 10 years ago. This is a thing that is hotter than any other technology that has come before it. But hot isn't always a good thing. We got some fires, okay? A lot of stuff is getting burned, and it's not actually fine. We have a lot of flexibility, we have a lot of capability, we have a lot of power in how we build these networks, these technologies, how we keep adapting them. We don't really have building codes for building code. Now, something I want you to realize, our cities used to burn, okay? Like London burned down in 1666, and from like 1830 to like the 1870s, we had, I don't know, Seattle and Chicago had a couple fires. New York burned 3 times. San Francisco burned in 1906. You know what all these dates have in common? They were a long time ago, okay? We got our act together. We figured out, we had to put out a lot of these fire stations. We need to have fire exits so people can get out of burning buildings. We altered the way we do things because the society that we lived in, these cities, needed to not fail all at once. As wonderful and as brilliant as internet technologies are, if we don't get our act together, people are going to leave. NTIA over at the Department of Commerce just did a study. They found half of the American browsing public is starting to back away from this whole internet thing. There's like, okay, that's cool. What's the privacy? What's the security? Am I getting another breach report? Is my credit card going to get shut down because I bought a cookie on, coolcookies.com? People are getting nervous, and they probably should be. So what are we going to do to make these problems a little more manageable? And so what I want to do today is kind of give a talk and say, how are we going to fix this? There is a thing that I see a lot of. What I see is what I call security nihilism. There's a belief that there's just nothing we can do. Failing left and right, it's just kind of what technology does. We pick up the pieces. We hope no one gets fired. But there's really nothing we can do. Hackers are always going to win. You know what? I am a hacker, and I'm here to tell you we don't always win. Okay? There are defenses that work. We have made things better. I was there 10 years ago. I'm here now. And I'm telling you, a lot of code has gotten better. A lot of code's still terrible. But a lot of other code's still actually improving. We're going to make things better. Because we have to. We can't go back. I've never in my career received or sent an inter-office memo. No idea how that works. We have to talk about how we're going to make things better and not care about the security dogma. It's not working, so we might as well try something new. We have 3 challenges that I want to talk about today. How do we not lose everything when we're hacked? How do we look at our networks as collections of individuals, of users, and not locations with particular data center implementations? How do we look at the world as the apps that people want to use, not the email exchanges that people are using instead? It's kind of the lenses that I'd like to talk about in this talk. So let's start with not losing everything. Who here knows about password databases and how we're supposed to protect them? All right, let's check it out. There's sort of this dogma, we've got to authenticate to our systems. There's a database, has a bunch of passwords in it. There are things that we're supposed to do to protect that database so that when it is compromised, it's not an immediately exploitable situation where all your users can be impersonated. And, it involves a bunch of impressive and complicated cryptographic math with hashing and loops and quote-unquote memory hardness. And, you do get some security value out of this. But there's kind of a presumption baked into the system that you're going to lose your entire password database. The attacker's going to have all of it. And then after getting through all of this effort, they're only going to do so much work to attack it. They're not going to go ahead and, spend $20 on the Amazon cloud. They're not going to do this or that. Let's be honest, it's victim shaming. It's a real problem in security. When someone gets hacked, here's the social rule. If you can't punish the attacker, you punish the defender. How could you be such a terrible human being that you were hacked? You must be a monster. That's why you were hacked. You're not at all like me because I'm not a monster. It's all shaming. Nothing to do with engineering. There are assumptions guiding our technology decisions. Assumptions like that we can't protect our data. be fair, in a lot of places we can't protect our data. But here's another way to look at the world. Look at this cash register for a second. What's interesting about it? No, not just that it's like Fisher Price and bright colors and whatnot. You know what's interesting about cash registers? Like you go to 7-Eleven, there's some money in the cash register. You know what's not in that 7-Eleven cash register? All the money. They don't have the entire corporate payroll at every single store that they have because they got a lot of stores. And you don't do that because that would be ill-advised, okay? We do this a lot in information technology. The real game to play is rate limiting. Rate limiting is risk management, but it's words that actually mean something, okay? Like, I'm actually going to tell you, hey, here's a thing that we should do. Let's talk about how we're going to do it. How much can you lose, or how little more accurately, before somebody notices and halts the loss? It assumes you're going to lose something. But be really nice if there was an announcement about a credit card breach and hackers breached major credit card database. 105 credit card numbers were lost. That would be such an improvement. We do assume that there's actually going to be somebody who's going to notice things. We're going to assume that there's somebody who does notice things can stop the loss. These are the assumptions that we're trading in. Versus we're just going to lose the data and maybe a little bit of math will stop an attacker. These are actually the more reasonable assumptions. Somebody's going to have to notice things. Yes. Your networks are not going to be entirely automated. You're going to have to hire more people. This is not just going to run itself. We also needed fire inspectors. These people, they're not necessarily going to work for you any more than the fire inspectors did. It might not be so bad, okay? They're outside your political system. They only care about the facts. Is the thing going to burn down? Could be terrible, right? Regulation is not pleasant for any industry. General strategy out there is we fix our things before the regulators come in and make us fix them. Either way, there's going to be human eyeballs on things. And the game is making it so as human eyeballs can be as efficient and as correct when they block things, when they shut things down, when they get in the way. Very, very easy to invest in the wrong security technologies. Can it scale? Is it actually possible that the things that we need to protect can reasonably be rate limited? If you have to do something 10,000 times a second, you can't hire enough people to look at 10,000 operations a second. But here's a really interesting thing. And I want you to think about this in terms of your own systems and your own assumptions about them. I asked a top 10 e-commerce platform that unfortunately I cannot name how often their password databases, which have like an enormous portion of the American public and truly the global public in them, how often is your password database even hit? And I assumed it was some huge number, 10,000 times a second, 1,000 times a second, 100 times a second. You know what the actual number was? 7. 7 times a second, they needed to find out if a password was correct. Why? Because they had other things cached in browsers, cached in devices, where there was a persistent token and they didn't need to find out if the password was correct because they didn't ask users their password because users hate that. Passwords suck. Bad technology. Turned out there are only 3 consumers for the mass compromisability. The ability to go ahead and get the entire password database all at once in one particular query. Okay, the backup guys needed to do it. Fine. Hackers. Oh yeah, those guys really want to go ahead. They don't want to stay in your network. I mean, they're going to, but they don't want to have to wait around for the data. They can just one shot get everything. That's really what they want. There are third consumers, developers. They didn't have time to know how to build some limited architecture. They just wanted to go ahead and get their job done and move on to something else. This is another word for technical debt. The actual fundamental job of this system needed to work 7 times a second. Maybe in a spike, 14. Didn't need to be able to lose the entire thing all at once. It wasn't a requirement. So how do you recognize, outside of just password databases, we got lots of things in our networks, how do you recognize something that could be reasonably rate limited? Well, there are 2 kinds of common queries that our systems need to service. There are aggregations across many records. You go ahead and you have something that actually does touch everything in the database. It is a wide query, but it's very shallow. It's incrementing values. It's looking for statistics. This is one kind. You go for everything, but very little gets out. Or you have a deep inspection, but on individual entities. It's a narrow query, but yes, it's deep. Little is touched, but what is touched is in fact deeply inspected. Our architectures know about these patterns, okay? Performance engineering, reliability engineering, the way you build indexes, literally the software you choose to deploy really actually is guided very much by, is this a wide aggregation or a narrow inspection? Security has not thought about the world this way. I'm going to tell you, we're a weird breed of engineer. Like, we're engineers, we care about stuff. We care about other people and how they're going to mess with our stuff. It's we kind of like to call it player versus player programming. It's a different set of concerns, and it means we don't deal with a lot of this stuff. But it's kept us blind. It's kept us blind into the fact that we now can break down, we can segment our systems into things that don't need to be rate limited because the aggregations are not very exploitable, and things that have a rate to limit and honestly are not being hit 10,000 times a second. This is how you decide, wait a second, we can re-scope our risk. How do we do this? A lot of fun stuff to talk about. Well, what is the actual mechanism that we use? There's been a lot of talk about microservices lately. These are small batches of code that kind of live independently, almost of even a server infrastructure. It's a separation of you don't have this big monolithic system. You have a little blob, and it does a thing. There's this real promise of microservices to separate and especially isolate our security rules from the systems that they're protecting. There's something interesting that happens when you're able to separate policy enforcement from the complex systems behind them. As a hacker, I may go ahead and see a particular thing and be like, hey, there's 50 endpoints here. I compromise one, and the entire rest of the system collapses. Be nice if our systems weren't so, say, fragile, if they had some independence and isolation to them. Security layers that live aside from the protected resource aren't compromised when any part of that resource is. This is especially true when you have something relatively agnostic like a rate-limiting architecture, where you don't care what the data is, you care how much data is normally leaving. So it's like, hey, you can do whatever you're going to plan to do, but I'm still going to see that suddenly you're trying to drag out the entire database at once. You do have to make sure when you develop these systems that when someone breaks in, and they do, and they're trying to exfiltrate data, they have to go back out of your rate-limited architecture. Okay? If someone goes in and says, psst, give me all your goods, but don't go out through the little channel, go out through the big back door. There are lots of big back doors. Set up network channels, routed out over DNS. It's a thing. Apparently some malware is starting to use it. Why does everyone mess with DNS? Such a nice little friendly protocol. So you got to make sure that there's no back doors out of your rate-limited architecture. You also have to make sure that attackers can't route around your protection layer. This is an incredibly common failure mode. Here's what it looks like. Okay, you've got some resource, it's unprotected. So you go ahead and you put up the protection layer and say, hey world, go to the protected part. you got to close off the unprotected thing too. Always ask yourself, is there something special about my separated protection layer so that an attacker has to go to the protection layer? Can't just do the other connection, route around. It's a really common failure mode. Places with DDoS protection layers, places with web application firewalls, where there's in fact a safe system, but the unsafe stuff is still around. It's like a password prompt that's optional. Sure, if you want to put in a password, it's cool, but you could also just go to like the admin interface anyway. Don't build that. People often end up with it. It's a big problem. So we've talked about the ways that we might build rate-limited architectures and some of the warnings about how you'll fail when you try the first time. Gotta always care about your failures, especially when you're building security technologies. You're gonna screw it up the first time. It's okay. Let's get a little bit more user-centric. Let's look at how people are actually using our systems and failing in some serious ways. I'm going to talk to you guys about ransomware. Ransomware is one of those things that's been a boogeyman, thing we've always been worried about, like people flashing BIOSes and putting malware on the admin side of hard drives. You know there's more to a hard drive than just like the spinning disk, right? There's another computer in there. You can hack that one too. Lots of boogeymen in security. One of the realizations we have is the set of things that can possibly go wrong much larger than the set of things that actually do. Well, ransomware is a thing that actually finally started seriously happening because, like I like to say, hacking used to be about kids. Now it's about people with kids who want to feed them. So they're stealing a lot of money. It's a problem. The way the ransomware attacks tend to work, something in an organization is hacked. They get someone to load a bad ad or they click on an attachment, whatever. They break some desktop. There are widespread vulnerabilities that live only on resources that tend to be on internal networks. There's a Java serialization vulnerability that is very common in JBoss, Java-based systems. When you hear that a lot of hospitals are getting hacked, it's not that the bad guys particularly hate doctors or patients. It's just they really commonly have this particular set of vulnerabilities that if anyone gets inside your network, it's incredibly reliable by design code execution. Kind of ugly. So what happens is they get some random desktop, they hack the main servers, they get everyone's systems, they encrypt everyone's hard drives, and then they say, hey, if you want to get your network back, you got to pay us a bunch of money. You know what people do? They actually pay up because it's pretty much always cheaper. They just happen to have to, shut down hospitals and possibly kill people, right? Yeah, that's all. Ransomware depends on the concept that you can lose your data all at once. Well, let me ask you a legitimate question. How often do you legitimately want to be able to lose all your data all at once? Who is this person that we're providing this service to? Can we design against this? Okay. Assume for a moment your employees are creating a gigabyte of new data a day. Assume you got 1,000 employees. That's an entire terabyte of new data every day. Okay, that's like $59 at Amazon. Now, I'm exaggerating a little. It's not really $59 a day to store an extra terabyte, but it's also not like $59,000 a day, okay? Our systems have the ability to lose everything a little bit. I don't say laziness. It just hasn't been a design characteristic to have a property that technically we refer to as immutability, which is that once you've created data, there's actually not the ability to uncreate it, to delete it. Now, You might notice, if you pay attention, that I'm being a little self-contradictory. If everything is being stored forever, doesn't that mean that everything is being vulnerable forever? That we're in fact dramatically increasing the rate at which our data can be lost because we just have more of it? And even if we shouldn't have gotten it, I've heard of a lot of breaches where it's like, they were supposed to have deleted that data a year ago. Why did it leak today? Well, we forgot to delete it from our backups, and they got into our backups. So you might say, Dan, you just told us to have less available to the attackers. Now you want more? You're right. But here's a kind of fun thing about that we can do from cryptography. You can encrypt data without the decryption key being online. In fact, that is actually literally what ransomware is doing, right? You could back up your data and not have the online capability to decrypt it. This is the inverse ransomware model. You go ahead and you never delete data, but you do always encrypt your backups and not have decryption available. You go ahead and get the decryption key if the ransomware guys show up, but if your random hackers show up who want to go ahead and raid your backups, the backups are encrypted, there's nothing for them to go after. You're actually taking the ransomware pain in the butt and you're putting it onto other bad guys. You're twisting the model around on them. Kind of fun. Now here's the thing. In order to be effective, these sorts of strategies need to be spread across groups, divisions, teams. They have to be immune to your politics. Because, you can't just be like, well, HR didn't get hit because they were protected, but okay, some other departments. It's like saying, well, the spleen was fully oxygenated. Too bad the rest of the organs starved for oxygen. You're still going to die. You got to be across the org. Hackers don't care about your org charts. They don't care about who's in charge of what. They see your networks as one coherent system that they can go after. If we're actually going to defend them, we have to defend them as a coherent system as well, somewhat independently of frankly, who's in charge. There's an ambient nature to effective security. There's an ambient availability of the resources necessary to protect ourselves. I've heard ransomware discussed in some circles as almost what people deserve for bypassing IT. People are doing their job, or at least they're trying to, okay? The worst thing I ever hear is when people are being like, I can't believe that person opened up a PDF and got our network infected. You know what? That person works in HR. His job is to open PDFs from the internet and read them and figure out whether to hire someone. And if he doesn't do his job, he's going to be replaced by somebody else. Someone has to make it so that he can go ahead and read PDFs and not expose the network to ransomware. Going ahead and blaming the victim is not going to secure anything. Ransomware as a technology is exploiting the interconnectedness of our systems. They're not interconnected by accident. This is how working systems evolve. HR reads the PDF, finds the person that would be useful for engineering, that person is hired. These systems are bound together. We have to keep them working. Effective security has to operate on a cross-organizational scale because the risks, they're just never scoped. The services that we provide have to be ambient, they have to be consolidated and coherent. They won't be perfectly uniform, but they have to be a thing people can expect, that there's something there for them. I actually think a lot about the success of Amazon's web services. And I'm going to tell you, they're not necessarily the best cloud in the world. There are pieces that are better in Azure. There are pieces that are better in Google. But these guys have been growing a thing for a while that in some very real ways work together. It's not perfect. You create a new server in EC2. It doesn't show up in DNS in their Route 53 implementation. You got to build that themselves. They got a thing that I'm really interested in lately that I've been spending a lot of time playing with called Lambda, where you write a little bit of code in JavaScript or Python or honestly whatever you want. There's a way to get it to work. They run the infrastructure. They run the mechanisms. They spread it out. They scale it. And just by the nature of the containerization they're using, the resources are completely independent of whatever it is. They're not tied to any particular server. When I was talking about microservices as a way to implement rate limiting, this is a coding model, but it's also a deployment model. It's also this isolation model. And it's the kind of stuff that's ambiently available. You can put this stuff in front of every service you have. I look at Amazon and I'm like, wait a second. One of the big reasons they're succeeding is when you're asking yourself, how am I going to do X, Y, and Z, there might actually be a thing there that's already pretty much what you need. And when you look at the profit statements, a lot of people have taken them up on their offer. We certainly do. We're a giant Amazon customer. Rewards. Rewards are scoped departmental competencies. It's why we have different departments. They go ahead and they figure out what they need to do. One of the biggest, I'd say this is almost one of the more controversial positions that I hold. But I never believe in the top-down model. I don't think it works. I don't think that any individual centralized IT organization necessarily knows what particular departments need in order to be successful. Especially in security, where we really think we're the expert in the room, we're not the only experts in the room. People know their own things that they need to be successful. One of the reasons why so many departments are using so many different IT solutions is because there's just a lot of and when I showed you that slide at the beginning that talked about adoption of technology, once upon a time, it was a small priesthood that knew how to make computers do stuff. Okay, everybody coming out of college knows how to use the internet. Technology is not technology anymore. It's just ambient. It's normal. It's boring. Phone calls aren't tech. Mail isn't tech. Email or normal mail. Turning on the lights or breathing air-conditioned air, driving. Everything behind them requires significant engineering talent to implement, and all of that talent has been abstracted away, and this is a good thing. It's the whole point of civilization. This is good. We're in the business of making everything this boring, while, by the way, making everything safe and secure. Cars shouldn't blow up either. Let's talk about networks. Your network should not look like. When you are building security technologies, implementing security, if you're putting in your firewall rules by pointing out, hey, network, allow port 443 on TCP, your network is doing it wrong, okay? It's not about 443 TCP. It's about allow all encrypted web access. It's about allow all users and partners to access this sales database, provided we know who they are and the link is secure. Our networks need to understand the semantics of our users. It's not our users, and us as administrators need to understand the semantics of the network is looking for the bit pattern that equivalates to 443. We don't write assembly code when we program. We can't be writing assembly code for our networks. It's cool to know 443 TCP is TLS. It's cooler to have the network understand security rules in terms of the business relationships. I'm actually really interested in microsegmentation. Not just because it means that we're much tighter controlling what machines talk to what machines, but because microsegmentation ultimately means the network understands what we're trying to do, understands that users have needs, and they don't want to express the needs in network speak. They want to express the needs in their own speak. And this is still hard because our actual requirements from the business domain have gotten hard, okay? We don't just have our employees. We have employees and consultants and contractors and vendors and temporary staffers and partners and customers, potential customers. need to be authenticated and understood and integrated into our business rules. Who knows where those people are? And frankly, who cares? We don't trust someone because they happen to be physically located in Manhattan. So we shouldn't be trusting people because what IP address ranges they have, what networks they're living on, even what networks they're living on inside our own organizations. These are bit patterns that are not meant for human consumption. Things have to be linked back to the actual business semantics. So we've been building our authentication stacks to deal with the complexity of all the business relationships that we need to understand. We moved to single sign-on because we didn't want to have different passwords for web and VPN and Windows domain and this and that. Well, then we moved to federation because we were authenticating to more than one organization. There was no single to sign on to. So we're like, okay, well, we'll figure out who the orgs are that we need to deal with. Eventually, it became clear we had too many orgs. And so there's a lot of work consolidating our federated solutions, going ahead and finding the resources necessary to not have a million different solutions. Part of this involves standardization and picking solutions, picking winners. Part of this is having an intermediation layer, an aggregation or consolidation layer that is actually what we deal with. If you think this is hard for you, who come out to Vegas to a big Citrix event, to who's listening to me talking about security, the teams that we need to support, this is 1,000 times more obscure to them. So what do they do? No, really, like what actually is the status quo? What's the alternative? Because there's no demands, right? Somehow these problems are going to get solved. It's not just hackers that don't care about your org charts. Everybody's making IC decisions. And frankly, it's what I like to call a SaaSapalooza. People are going ahead and they're bringing in lots and lots of rogue third-party partners. What's their security policies? Who the heck knows? We talk a lot about the threats of Internet of Things. I don't know any toasters with my social security number. I actually do know of software as a service providers that have it. The whole signature space. You want to get a document signed? You think you're doing that with Acrobat? Acrobat's become a disaster. HelloSign and DocuSign own this space. These guys have tax information on so many people. How do they store it? What are their policies? What are their procedures? These systems get used because it is orders of magnitude easier for neutral third parties to host a service for two mutually distrusting organizations than it is for either one to host a service for the other. It's a lot easier both politically and it's a lot easier technically. And by the way, their interfaces tend to be pretty good because they have to actually be pretty good to attract users. They can't just be the default solution and handle PDF like Acrobat or be the blessed solution by IT. They have to be so compelling that they become viral, and then they actually do. And look at these security models that these systems actually have. This is a Gmail system. Look how nice and rich this ACL system is, this access control list. Here's a link to share. Go ahead and you can actually declare people in the Google ecosystem, which is like, 80% of people. You can go ahead and have really fine-grained but appropriate things. Prevent editors from changing access, disable options to download, and it's all actually tied to the person who is doing the work, not IT that's a support call away, and maybe a meeting and discussions about the appropriate ways to do things. It just happens. It's actually kind of what we'd want in the world. What are our choices when we're dealing with this? One is to provide internal services that people don't look externally. You can do this. You should. Go for it. You got to make sure people know whatever you actually do exists. This is hard, okay? Your internal resources, no matter how good they are, don't show up when people do a Google search for how to solve a problem. Life right now is, I got a problem, I put it into Google, I get an answer, I go do that. I like to call corporate intranets the internet without Google. It's not that there aren't certain security advantages to obscurity. Attackers need to go ahead and discover what to hit. They have to do real-time discovery, and in that discovery, there is a risk of themselves being discovered. But attackers are learning. They're pretty patient. We don't talk enough about the disadvantages of all the good work we do on our networks not being easily found. It's like, the Dr. Strangelove problem. What use is an amazing new internal technology if no one knows that it exists? I mentioned there's a lot of value to people being on the same page. I asked CFO, what solution he liked for teams to be able to track their work efforts. It's like, I don't care what people use. I just want them to use the same thing. I don't want this engineering team using Jira and that engineering team using Trello and that, I just want one. So there is value to, I don't want to say top down, but at least some consensus building. But there's risk in random partners, okay? Target was hacked via their HVAC, okay? Literally, it's like Hollywood. They actually came in through the virtual air ducts. Who are the partners we end up with? How do we control their use of data, monitor their involvement in our organizations, get some kind of policy around it? I don't see rogue software as a service consumption ending any more than I see us being able to specify a small list of websites that people can browse or small list of words that people can speak on the phone. I just don't think it's going to happen. Here's a possibility, kind of crazy, but I'm going to go ahead and say it. We could just pay people to have good policies and to commit to them, right? Like, we have all these complex authentication technologies that we normally just use to say, hey, yes, this is this person at our organization. We could also say, hey, if you're a software as a service provider that is so compelling, our users have decided to use you, okay, we'll pay you 50 cents per user per day our user is using you, which we can monitor through our authentication tech. Sign up for these policies. Now they can lie, but now they have liability. They get hacked. You can sue them. You can actually make those sorts of deals. They can decide if they want to sign up for an information flow. Guess what? They may be making nothing. What if security isn't just a stick that we bash people over our head with? What if it's cheaper and more effective just to pay them? Hey, go ahead and have some competent security policy, please. Thanks. It's an idea. We've got to think past the dogma. Last thing I want to talk to you guys is about apps and not email. Why is everyone going to all these links anyway? Well, email. Email is not scaling. It's become a really terrible technology. I like to call emails like a meeting where you don't know anyone's come in, you don't know anyone's left. People are starting up side meetings. Maybe they're not paying attention. No one ever has to make a decision. This is not great tech. When you don't have the sort of automation or integration or work that these apps are doing, email is how things get done. Requires a worker. Requires a worker to receive an email request to go do something. They hate it, especially if they know it could be automated. The nature of work is shifting from do this thing to automate this thing. Somehow secure this thing needs to be part of the conversation too. Look, security doesn't like email either, okay? I hate the thing. It's unencrypted, it's unauthenticated, but man, it looks like it's authenticated. You see someone's email address there. That's Bob. It says right there, Bob. Totally Bob. The only good thing about email is, unlike all these big document stores with signatures, theoretically there's no big store of all your email in the sky. Theoretically. Remember that thing I said about it being unencrypted? Unauthenticated email is really starting to cost us. Having a lot of business processes be on something where you don't really know who you're talking to. Anyone hear about the Ubiquity scam? Yeah, so someone pretended to be the CEO of Ubiquity, telling the bank to go move some money, and they did. $41 million cash gone forever. More common, huge numbers of companies are having these scams where the CEO demands that W-2s be sent somewhere. Why? We don't actually know, but I don't think it's going to end well, do you? So, email is this inefficient, insecure, widely disliked technology we're figuring out how to replace. And we're starting with services. Services that we want to request stuff from, services that we want to offer. Because nobody wants to email support anymore. Nobody wants to call support. Whatever we use has to work across organizational boundaries, because email does. And for the love of God, it has to actually be authenticated so we stop losing $41 million in single scams. So, the way I see it, we're going to be offering a lot more APIs. We're going to be consuming them. We're going to be offering them. They're going to be much more strongly authenticated. APIs are the new perimeter. They are the thing that is going to be replacing asking people for stuff. You're going to be exposing your data to outsiders on a regular basis. You're going to be consuming data exposed by others in your processes. We've been doing this to some limited degree with web-based APIs, and I think it's going to expand past them into the underlying backends. You know, how many content management systems are a front end with JavaScript and a back end with MySQL or some database back there? We're just going to start exposing the back end. A little scary, right? Because huge chunks of the security model were in the front end. They were in the thing that went ahead and formatted the back end's protocols. So when we go ahead and we say, fine, here, have the back end, do your own queries, do your own work, where'd the security go? We build a lot of firewalls, web application firewalls that are actually application aware, that are going to need to adapt to this new future of deeper protocol exposition. Because it's going to happen. It's a lot better way of dealing with things. The web frameworks themselves had a lot of limits in flexibility. But how do we secure it? So I do see us getting towards a world of API firewalls that deal with the sort of REST APIs that may or may not be automatically built. It's a really interesting system called Postgres that turns your Postgres schemas into REST frameworks. There's also just, there's a lot of these bi-directional protocols that are really a lot richer than what we've been able to do with request response REST that hadn't been exposed over the web because people didn't realize, say, WebSockets lets you do that now. Those protocols are going to be exposed outside of our organizational boundaries. We don't really have the gear in place yet to protect them. So APIs are not yet first-class citizens. They're going to become first-class through the magic power of biz deals. They're going to become major endpoints to monitor. So we're going to have to deal with randomly selecting system transactions, anomaly detection, tripwires, honeypots. We had sort of a rate limit built in when you had to email a guy, because somebody is going to notice that's a really weird request for $41 million. As we go to this sort of automation that doesn't have the firewalling in place, you're going to lose a pair of eyeballs that are afraid for their job. So it's going to get a little weird. Okay, let's deal with that. We can do better than we're doing today. So I've talked about our challenges. Let's talk about kind of more mindset stuff. Ultimately, it's not about your data center, okay? No one cares how you're providing services. They care about the services that you're providing. It's about the data, how it's generated, how it's exposed, how you're going to protect it, no matter what system you're using. Internal on-prem, in cloud, I don't know, from a satellite in space, whatever it turns out you're using, you're going to take new approaches to security. Don't be afraid of trying new stuff. It's not like the status quo isn't on fire. We got to try new stuff. Some people think that security should be like the immune system, automatic and invisible. Okay, anyone here actually have any background in medicine? The immune system just destroys a whole bunch of stuff. It just happens to destroy the bad stuff a little more frequently. Equivalent of the immune system, and let's just fire lots of people. Eventually, the ones left will be too afraid to do anything insecure. Yeah, it turns out that's a cure that kills the patient. Don't do that. Security could be a little bit more like medicine. Snake oil is not some euphemism, okay? We used to take snakes and turn them into oil and sell them as a cure for whatever ails you. We had to figure out as a society how to not do that anymore, and we kind of did. Most of the pharmaceuticals on the market, they were terribly expensive to research, but they do work. We are at a moment in history where there's an unambiguous mandate. 500 of the Fortune 500 are getting wrecked. We just don't talk about it much. And small business is under siege a lot more than we'd like to admit, okay? You know, what if the corner store had to defend against the Chinese military on a regular basis? You know, the corner store would not be a small business. What if it stops being viable to have a small business? So we have a lot of people that are trying to figure out how to build things, what to build. We have a lot of existing talent doing IT projects. We have a lot of new talent learning how to code. This is an opportunity to watch, to monitor, to experiment. Take 10 teams and have it build it one way. Take 10 teams and build it the other. Come back after 6 months, look at the 20 solutions, figure out which systems led to which approaches led to which more secure technologies, more effective technologies. Like, just the scale at which we can do experimentation right now is enormous. This isn't limited to tech companies. There are no more technology companies anymore. They're just companies. If you aren't doing software, you're already almost out of business. So this is just how we do things now. I've had an interesting thing where I'm now spending time in DC, where we actually now say there's no such thing as technology policy anymore. There's just policy. I don't think that we're going to do all these things alone. I'm a little weird in technology that I have some faith or some belief in the power of government to help. I know it's a little controversial, but you know, when it comes to infrastructure, the interstate highway system isn't too bad. We actually did get rural electrification. Government does seem to have the ability to think on a larger time scale. It also seems to have this weird obsession with blowing things up and spying on everything. What I like to say is if government has a role to play, it's to be more than the biggest and baddest hacker in the room. I watched some stuff get protected for 10 years. I don't know about you. No one I know can work on the same job for 10 years. So there's some potential to help us. You guys are going to get dragged into the crypto war whether you like it or not. There's a big fight right now about whether the internet is too secure. I know it's a little weird, right? It's nothing you guys have ever had to deal with. But the Washington conversation is about privacy versus security, where cryptography has nothing to do with security. It's only that weird thing that privacy nuts seem to like. Okay? Well, you may think that it's not any of your business, but guess what? How many of the resources inside your networks are being exposed via HTTP, via unencrypted web traffic? Well, guess what? Browsers are deprecating unencrypted HTTP. They are getting rid of it because of what's happening on the public side. Features of the web are literally being locked to cryptographically secured endpoints. Now, dealing with this on the public side of the internet is actually getting easier. We have a system called Let's Encrypt. Machines can finally just go out and get their own certs. No meetings, no phone calls, no dealing with certificate authorities. What about your internal domains? What about your intranets? How are you going to manage all the certificates that you're going to have to be deploying so that the web browsers that a lot of your internet services are using actually keep working? Like it or not, this is coming. Look, we have some hard problems, but we are winning some fights, okay? What I have here is some work that I did with some people at Deja Vu Security. We actually looked at the number of vulnerabilities in Office in like 2003 versus 2010. Same with OpenOffice 2003 to 2010. And you know what? The software's getting better. We are seeing steep cliffs in vulnerability counts in places. It's not all bad news, okay? We have some hard questions we get asked. How do we run software that we know might be dangerous, you know? We're actually starting to get sandboxes and virtualized environments that are able to do stuff like read PDFs that don't and not get hacked after. How do we prevent bugs from being exploitable? Okay, so there's a flaw. Does someone have to get code execution on a network? Turns out no. There are ways of making flaws survivable. Microsoft finally went and said, hey, this one common class of bug in web browsers, we've mitigated it so effectively, we're not going to fix bugs in it immediately. We'll fix it eventually, but we don't think you're going to be able to hack it. And thus far, they've been mostly right. There are these enormous distributed denial of service attacks that are wrecking our networks. If you'd like to help us fix it, come find me after. There's just a lot of progress, and you can all be part of it. True expertise is not about just doing hard things. It's about taking these hard things that are haunting our systems, haunting our networks, and making them easy, making them manageable. Security is not enough for it to be better. What does better even mean? It's about making it cheaper. It's about making the cost scoped. There have been some enormous wins by very clever people at extraordinary cost. The next game is about making these costs ordinary, manageable. We need data, experimentation. We need gumption, try stuff. We need reporting on how well all of these experiments are going. Because it's not all snake oil. There are things we can do to make our network safer. I like to say you get the home you build. Our homes can be somewhere nice, or our homes can be on fire. It's still fuel. So, we can rate limit our losses. We can align to who our users are, no matter where they happen to be. We're going to be exposing rich APIs, because the alternative is begging people for service over email, and ain't no one got time for that. And you will be doing things differently and learning from the experience, because we can't maintain the status quo. More people use IT now than ever before. Help them. That's what I got to say. Thank you.
So Dan, thank you very much. We are open for questions. We still have about 2 or 3 minutes left. But before we do that, I just have one question for you, sir, and that is, I really like the whole APIs, the new perimeter piece, right? Mm-hmm. And what we're seeing people do is taking applications that were internal, just throwing them into the DMZ in the name of time to market, and then just saying, okay, it's okay, we're done, and skipping the whole security process.
It's a problem.
Yeah. And so one of the things I was curious about was, where does security live in that? Because if the API goes anywhere, if the users live anywhere, et cetera, you got stuff moving to cloud, stuff on-prem, users who are mobile. Does the security stay attached to the individual or to the app, or does the security stay in the infrastructure, and I consume that security in whatever infrastructure I happen to live in?
The way I see things working is, one, we make sure connectivity is managed a lot better through the authentication layer. So in other words, okay, we're going to have people who are going to need to be able to access it. They may be anywhere in the world, but you actually tie the ability to speak to the endpoint at all to strongly authenticating that it's an actually trusted party. And the other side that I see is, we just get a lot more protocol awareness in the applications, the quote-unquote API firewall, so that when these resources are exposed, we're able to both know what's going over them, be able to monitor, be able to detect unusual patterns, and we're able to even if the patterns are, we need to be able to detect that the patterns are unusual but well-formed. We need to be able to test malformed interactions as well, because we're losing a lot of the protections we got from when it was all just being exposed over the web.
Sounds great. This is app awareness, definitely. Any last questions before we take it offline? All right. Well, Dan, thank you so much for coming out. We really do appreciate it.
This was a great time. Thank you.